Hey guys, welcome back to Algos Explained. This is David Kim, and I am bringing you back these Code War videos. I hope you guys, I think you guys enjoyed them. I've received comments about people enjoying these videos, and so I decided, my schedule's been changing a lot, and I'm gonna bring these back. And so, yeah, I don't know if you've been checking out my whiteboarding videos, but those are gonna be on hold for a little bit, and I'm bringing these back. The way this is gonna be different though is that this is no longer like a first look video. It's going to be more like me just. It is still going to be me going through this, reading the question and then solving the problem, but it's no longer going to be me struggling through it. Like for this question already, I've already solved it and I have the code in front of me. And I feel like with this new method, it's probably going to be better for me in terms of explaining to you guys the process of really solving the question versus the process of struggling with it on the spot. I think they both have their benefits, and so for this one at least, I'm going to go that route. And so let's go ahead and get started with this. This question has to do with linked lists, which is a type of data structure. Um, Okay, cool. So linked list, insert nth. And so when you're looking at linked lists, you have to always remember, okay, is it a singly linked list or a double linked list? If you look at this one, they create this for you over here. And so it looks like it is a singly linked list, which means it only goes one way. Or it links one way, which means when you're on a node, you can only look at the next one. And if it was a doubly linked list, then if you're on a certain node, you could also look at the one behind it. This one only has a this.next function, and so therefore it is a singly linked list. If it had a this dot like previous or this dot before, some way to look back, then you would know that that's a doubly linked list. But okay, let's go on with the question. Implement the insert nth function, insert nth PHP, which can insert a new node at any index within a list. Okay, so we have a list, and they're going to give us, well, if we look at it here, they're going to give us the head, index, and a data. So pretty much it looks like they want us to stick the data inside the index of that linked list. And so insert nth is more general version of push function that we implemented in the given blah blah blah, given a list given a list and index and in the range 0 to length and a data element, add a new node in the list so that it has given it has the given index. Insert nth should return the head of the list. Okay, so no matter what, I guess, well, no matter where you stick it in, whether you stick it in the last or the first, they want you to give the head back. And so they have this bit about you must throw an error if the index is too large. Um, I got through this question without having to throw any errors. But again, I didn't fully attempt it, so maybe at that point, maybe we will have to struggle through it together. Um, but we'll see. Okay, so I kind of explained this part already. This is just the node being created, and yeah, pretty much what it means is if you have a node, if you have like a head or a single node for of the linked list, you can use this .data function on it, and you can use the .next function on it. Um, and so what that will do is pretty much if you do .data on a node, it will give you the data, the value of it, and if you do .next, it'll probably give you the node of the next one, not the value of the next one, but the node itself. Um, cool. So let's get rid of this and get started here. When I initially was working on this question, I first thought, okay, should I be making an entirely new linked list? Like, I have this head and I have an index. Should I be iterating through this initial linked list that I am given, and should I make a copy of it? Like maybe as I'm going through that linked list, should I make a copy of it and uh, return that? And I think that that is a valid solution. Probably is probably some people would prefer that just to not mutate the input, but the way I decided to go about it is I'm just going to mutate the input. I'm going to take the head and I'm going to literally inject the data inside of it, inside of the linked list I'm given at that index, and return the head again. And so let's go ahead and get started. Let's see. First of all, what I always like to do is I like to just go ahead and run the whole thing, see what happens, see kind of what errors I get, see kind of what messages I get, and so okay, look, it's just assigning me a server right now. But after that initial run, what I would probably do is I would return the head because they want me to return a node, right? And so I would go ahead and what is it? Return them a node and see what happens there. And so this is still executing me returning nothing. And so I get a bunch of errors. I pass nothing, fail 6, 5 errors. And so when we return a node itself, I'm expecting us to pass a couple at least. Maybe if the index was, I don't know, maybe if these inputs were blank, they would want the head back. It's taking a little bit today. Just bear with me. Yeah, I don't know why it's taking so long. Okay. That shouldn't have happened. Okay, I'm going to pause this video and I'm going to check out what the heck is going on here, and I'll get back to us. Okay guys, so I'm back and I've been unable to fix the issue. I think it's a server error, and so there's nothing I could do about that. Uh, maybe they change all their servers to something far away from me. Maybe because this is like, what is this? This is like 6 a.m. right now from where I am, and so maybe they send it over to Europe or something, or Asia or the East Coast or whatnot. I don't know. Anyway, this is not working out for me, and so, but what I do have is my past solution, and so I'll just show you over here, kind of what I did, and I'll talk through it with this over here. I don't even know they had this tab, but yeah, so yeah, the server's timing out, maybe due to high server load. I doubt it. I bet you the server was just moved to like a further place away from me. And yeah, I don't know. Maybe people are up on Code Wars a lot at this time, but who knows? It usually does not take that long. It's a matter of a second for it to usually run. But anyways, take a look at this. This is my solution from last time. And so what I ended up doing was I created a counter. I created a new node and a next head. And kind of I'm going to walk through all of this first, and then I'm going to explain to you guys. And maybe if you understand everything I did after I just do the initial walkthrough, great. That's good enough. But the explanation will come afterwards. So yeah, the counter is at 0. The new node is creating a new node. This is how you create that new node from this, pretty much from that. Next is going to be equal to the head. So this is pretty much another node that's been created, but it has the value of the head already. Um, I have an if statement here and a return head way down here that is not connected to anything. Well, it's connected to the function, but it's kind of at the end of it, we're just going to return the head. And so what happens here is if next equals 0, so pretty much, okay, if index is equal to 0, so index 0, then what does that mean? That means of these nodes, of this 1, 2, 3, this is just representing a node right now. That's the node, that's the index, and that's the data value. Just like here, head, index. But of course, when they give us the head, they're actually only giving us like that first representation of a node. That's just the value inside there. And so if they were to give us a 0, which is possible if we take a look at one of these, excuse me, pretty much what's going to happen, we're going to take that first node and we're going to make that into kind of we're going to make the 7 in where that 1 is, but we're not going to replace the 1. We're going to be shifting everything aside, which we can see over here. We didn't replace the 1. We just shifted everything away, or we pretty much, it's not like a replace. It's kind of just scooching in, just shoving it in, and making everything slide away. making everything make room for it. And so that's exactly what's happening. And so pretty much what we're going to have to do is, and this is already, I'm going into the explanation already. We're going to be looking at these. I'm going to explain these as we go through here because they weren't all created at the same time. So if index is equal to 0, which means it wants to be the first one, everything move back. What we're going to do is new node, which we created a new node with a data point, and that is, you can see from here that that's how you create it. The node takes in a data, and that will become its data. The next will be null because it's a single node, not part of any linked list yet. And so this is how we created it. New node equals, or new node, okay, the variable new node is equal to new node with the data inside of it, and that's the data that we want to kind of be inserted inside that index. And so new node.next equals head, and head equals new node. The reason why I did that was because I wanted to return the variable head. At this point, I guess I could probably just inside here, I can't, maybe I'll copy and paste it over here just so that I can mess around with it. Um, let's see, I said over here if statement, instead of this line, I could have probably just done like return new node, and that would have been good too. Simply because we of course, this else statement is never going to be looked at, and therefore, you know, we're never going to need that portion. We're never going to hit that return, so we could probably just return new node at that point. But I just decided to go along with reassigning the head to the new node, the variable head to the new node, and just return the head. Simply because the else statement is just going to work that way also. And so right now we haven't touched this variable yet, and we haven't touched the counter yet. We have explained the new node, how that was created, and we're going to use that again definitely. So what happens when it's not the index of 0? That means that it can be anywhere else. It could be 1, 2, 3, or within the indexes. And this might be kind of where that error statement they were talking about. I don't think I submitted it. Maybe that's kind of where it would have failed on me, but we could talk about that error later. So for a situation like these, let's take a look at these other ones, 1 and 7. So pretty much this is index 0, that's index 1. That's kind of where the 7 needs to be, so all these guys, they need to move back. And that's exactly what happens here. 7 takes the position of index 1, and everything's shifted back. They get to come after the 7 now. And same here, 3. Where's 3? 0, 1, 2, 3. Null is at the 3rd position, so pretty much 7 will take the position of that null and push null back. And so with that in mind, let's just go ahead and take a look at this else. Pretty much if it's not 0, because 0 was just like, it's an easy case that we could have just got taken care of, and so I decided to make that if statement there. For all other cases, and it is quite possible that I don't even need that if. I didn't try that. Maybe I probably should have, but I was just trying to get through this question at the time. So yeah, while counter is not equal to index minus 1, counter plus plus, next equals next dot next. And so that's kind of confusing here. I could have chosen better variable names, but right now next is equal to the head. And so I just had to create a variable for that. I had to replicate head. And so what happens here is while counter does not equal index minus 1, and that minus 1 also I added that in later actually. I initially had counter does not equal index, and I went with that. I got some errors, and then I kind of, on paper, I kind of wrote it out, drew out a diagram of kind of where these nodes were actually going, and I walked through uh, this code, and then I decided, okay, it needs to be minus 1. So yeah, counter does not equal index, which means counter, of course, or here we go, counter is 0, and index is whatever the index will be, say it's 1 or something like that. And so if the counter does not equal the index, which means, okay, if we're representing where we are in the linked list by the counter, we're not at the index yet. And so what happens? Okay, well, let's say the index is 2. And so counter does not equal 2 because counter, it starts at 0. what will happen? The counter is going to increase, and next is going to equal next dot next. And initially, what is next equal to? It is equal to head. Now this is going to be representing a variable on the left side, and on the right side it is going to be representing that node. And the reason why I made next equal to head was because initially, if you take a look at here, I'll change it. I had it as head.next, and that makes sense, except whenever we run this while loop, I'm only going to be getting head.next, 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 and it's never going to really progress further. And so I couldn't have that. Pretty much, I needed next to represent head, and then I needed to get the next to the next one and keep on going further in the linked list. And so kind of what happens here is, okay, counter does not equal index. Index is going to be, we said 2, and so 0 it does not equal 2. Let's increment the counter by 1, counter plus plus, so it will be 1 now, and next equals next on next. So pretty much at this point, if let's go here, let's do 1, 2, 3, and if we want to do the index at 2 and insert a 7, what's going to happen here? That I just made these values the index values, just to make it easy on us. So counter is 0, and next on next is now, next used to be head, so it used to be 0, but now it is the next of the head, next dot next, so it's head dot next pretty much, and that's going to be the 1. And so counter is now 1. What's going to happen there is still not equal to 2, and so counter gets incremented. Counter is now 2, and or well, I'm ignoring this part for now. I'm ignoring the -1, but I guess I shouldn't. I guess I should. I guess I shouldn't. I was gonna explain to you why the -1 happened, but why do that? Let's do this over. Counter was 0. If counter was 0, it's not equal to 2, right? And so counter gets incremented. It is now 1. The counter is 1. The next on next is now at that 1 value, and now we check counter is 1. Does it? If it does not equal, it 2 minus 1, so that's 1. So it does equal, so let's jump out of that while loop. Next right now is at the 1 value, and so let's go ahead and take a look at what is happening here. We're going to have a temporary node, which is going to be next on next, which is going to be, well, next right now is 1, and the next of that is 2. So temporary is the 2 node. And so what happens there? Next on next equals new node, which means the next of this guy was 2, but now it's going to be this node that holds the 7 value, and then new node dot next equals temp, which is going to be this 2, and you only need to do new node dot next equals temp because this 2 node holds its next values, which is going to be the 3 and whatever comes behind it. Yeah, these linked lists are kind of tricky if it's the first time you're doing it. I do have a whiteboard video on it, which I feel like it explains it pretty well. And so, yeah, I think if I add more to this video explaining this, it might just confuse it. So I'm going to stop there. And if you guys want to rewatch this portion, maybe that'll help. If you want to check out that whiteboarding video, that'll probably help too. But pretty much, yeah, that is it. What we had to do was pretty much the simple idea over here. Well, maybe not too simple, but the basic idea, and I say simple because for linked lists is always the same idea in terms of inserting and deleting. You have to work with these .next a lot. This is not bad coding here. Maybe the variable names suck, but you have to work with .next a lot, and it helps if you've done it before. But pretty much you have to have a temporary. You always have to have that, and you have to kind of assign the .next to different things and link them back together. And then of course at the end we're returning head. And so yeah, this video I'm sad that we weren't able to run through it, but yeah, hopefully you enjoyed it. Hopefully it helped you out, and if you have any comments for me, like, comment, and subscribe. And I always read the comments. And so, yeah, hopefully this helped. Catch me in the next one. Have a good one. Bye.